Question 4. Okay, express 3x squared plus 9x plus 10 in that form. I always used to do this with the comparing coefficients, the multiplying out. I'm not sure that any of you did that when you did this for me this time. Almost everybody did this thing where you take it and you try and write it so that we've got a 1x squared at the start. And then we try and work it out from there, so that if we've got 1x squared, we're going to have half of that, which is 3 over 2, inside our squared bracket. Now, if we had 3 over 2 in there, by the time we squared that, we would have 9 over 4. You square 3 over 2, you get 9 over 4. And so we'd have 9 over 4 too much, but we'd have it 3 times. So we need to take away 3 lots of 9 over 4 in order to keep it balanced. We've already got a plus 10 hanging around over here. So we would have that line, which would then give us 3 lots of x plus 3 over 2 squared, minus 27 over 4. And because this is non-calculator, you may find it helpful to think about 10 as being 40 over 4. And so all together we have 3 brackets x plus 2 all squared plus 13 quarters, and that was the answer. Now, we've seen that this class found it much more comfortable doing it this way, I felt. The other way that I showed you to do this would be to say that we want 3x squared plus 9x plus 10 to be 3 lots of x plus p squared plus q. If we multiply this out, this is 3 lots of x squared plus 2px plus p squared plus q. So it's 3x squared plus 6px plus 3p squared plus q. Now, if we compare coefficients, we've got 9x's there, and we've got 6px there. So that tells us, looking at the yellow bit, that 6p must equal 9, in which case p is 9 divided by 3, 9 divided by 6, sorry, which is 3 over 2. And if we look at the green bit, it's bound to be green, there, we get that 3p squared plus q equals 10. And then it's just working that out with the value of p that we've got. P squared would be 9 over 4, so that's 3 lots of 9 over 4, plus q is 10, so q is 10 minus 27 quarters, which gives us the 13 over 4 that we got a moment ago. So you can do it either way and end up with those values. If you do it this way, the question did say write, express in the form. It didn't say find p and q. So you have to finish this off by writing. So the answer is 3x plus 3 over 2 squared plus 13 over 4. As I said, I don't mind which way you do of those two ways. My class last year all preferred this way. This year you seem to prefer the top way. As long as you get it right, that is okay. State the coordinates of the minimum point. Because we've done differentiation, if you wanted to, you could start again, differentiate it, and put it equal to 0, and do it that way. But that's a lot of work, 2 marks, just to get the coordinates. We should be able to read it straight from here. Remember, the x value that makes it a minimum is going to be whatever makes that 0. So the x value is minus 3 over 2. And the y value is whatever you're left with if that bit is 0. So if that's 0, 0 times 3 is 0, we're left with 13 over 4. And that would be the coordinates of the point that we're looking for, or you could write it as coordinates if you want to as well. These were both follow-through marks, so if you interpreted whatever you'd got in here, if that was wrong, if you got the right result here from what you've done there, then you would get the marks. Calculate the discriminant. Now the discriminant is just the bit inside the square root sign in the quadratic formula. It was 3x squared plus 9x plus 10. So, b squared minus 4ac is all that we're after. That is 81 minus 4 times 3 times 10. We've got 81, take away 120, which leaves us with a value of minus 39. And that's it. That's all it asked for. It didn't ask you to interpret it. So if you went on to say, therefore no real roots or anything like that, that was irrelevant. It just asked you for the value of the discriminant. And that was it. Notice no square root sign. So don't put the square root sign in there. It's only b squared minus 4ac that we want.